All right, let's talk a little bit more about this concept of a rainbow in a continuous spectrum. Now, does everybody recognize this diagram right here? All right, so this diagram is called what? Electromagnetic spectrum. So here we are focusing in on the energy of waves. And basically, the higher the energy, the different types of waves you have. The lower the energy, you have various types of waves. Radio waves are your least energetic waves. Gamma rays are your highest energetic waves. So if you look somewhere in the center, you come close to the center with what we are able to see with our own eyes, this visible light spectrum. So this small little area right here on the electromagnetic spectrum is what we can see. You can see slightly higher energy waves are ultraviolet, slightly lower energy waves in the visible light are infrared. Go ahead and jot down this table real quick in your notes. So today, we are doing something called the flame test lab. Flame test lab. And basically what we are looking at with the flame test lab is the energy given off of particular atoms when you energize their electrons. So, what exactly do I mean by this? Well, take a look. If we look at the structure of a Bohr model for an individual atom, let's just say hydrogen. So here's hydrogen. Here's my first energy level with 1 electron. Here's my second, third, fourth, fifth, sixth, seventh energy level. We're going to just take a slice of this right here. Okay, we're going to look at a slice of this Bohr model. So if this is my nucleus, whoa, what happened there? This is my nucleus. Here's my first energy level right here. Here is my second energy level right here. Here is my third energy level. Here's my fourth, fifth, sixth, seventh energy level. Okay? So, does everybody kind of see where we're at as far as the perspective of what we're looking at? Everybody see that we just kind of taken a slice of our Bohr model and we're just looking at it upright? Is that okay? So if we look at hydrogen, hydrogen has 1 electron in the first energy level. There it is. Now, is anybody babysitting here? Okay. Does anybody try to give a kid a bunch of sugar before they're supposed to go to bed?
Yes.
Why would you not do that?
They sugar crash.
Well, they don't crash right away. What they do is they get highly, highly energetic. They get very hyper. They get put into an excited state. Ooh, that's not how you spell excited. So if you give a kid sugar before bed, they will get into an excited state. Everybody agree? Yes. Now, what do they have to do to get out of this excited state? Well, they have to use up their energy. They have to give off their energy. So what do? They will be running around the house. They give off a little energy when they do that. They'll be hanging from chandeliers. They'll give off a little energy from that. And finally, they'll go run around the block and give off a lot of energy from that. And eventually, they'll come right back down to the ground state they started at. Now, let's take a look at what I just showed you here with this diagram. If I take an electron and provide it energy, how can you provide electron energy, by the way? Hey, how about we set it on fire? So we provided energy through a flame, and here we excite our electrons. It will hop up to a higher energy level because it has higher energy. Make sense? We call this an excited state. An electron that is not in a ground state is in an excited state. Now, in order to get back down to where the electron belongs, it has to give off energy. And in terms of giving off energy, it will give it off as radiation. Now, the radiation is slightly different depending on where the electron is falling to. So electrons will fall in succession through the various energy levels. So in this case, if I have an electron that started out at energy level 7 and falls down to energy level 3, this is kind of a small distance, we'll give off infrared radiation. If I have any electron that falls down to energy level 2, this is a slightly bigger distance. This is visible light. And if I have electron fall anywhere all the way back to the first energy level, this is a pretty big gap. What do you think will be given off? What's higher energy than visible light? Ultraviolet. So anything falling down to energy level 1 will give off ultraviolet radiation. So here is the essence of what you're doing today with the flame test lab. You're going to take various atoms, you are going to put them in the flame, and you're going to test to see what radiation is given off. Now, what are we going to observe? Out of all these, what can you observe?
Visible light.
Visible light. You can't see the infrared, you can't see the UV, all you can see is the visible light. Can you distinguish between various visible lights? I hope so. If not, you would be considered colorblind. You should see, based on the substance you have, various colors being produced. All right.